Welcome! In this experiment, you'll measure the equivalent weight of a metal. Having said that, you might well ask, what is an equivalent weight? Let's answer that question. Equivalency in this experiment is related to the hydrogen ion. Now, metals with electron potentials more negative than hydrogen will react with acids, that is the hydrogen ion, to produce the metal ion plus hydrogen gas. The equivalent weight of the metal then is the mass of the metal, which will react with 1 mole of hydrogen ion. Now, the relationship of an equivalent weight with atomic weight is fairly simple. The equivalent weight is simply the atomic weight divided by the charge of the ion which is formed in the reaction with acids. Let's look at an example of the metal reacting with hydrogen ion. We have 2 pennies here. We've notched both of them at the bottom so to scrape off the top layer. And now we're going to put in some HCl and we're going to see what happens. After a couple of hours, the 1981 penny still looks the same, but the 2004 penny is actually floating. It's still bubbling and it's floating. Now, why do you think that is? Let's get back to the experiment. The procedure for measuring equivalent weight requires some preparation before you can actually start. First of all, you must calibrate a burette so it may be used as a gas burette. Next, you will make and standardize some 1 molar HCl by diluting 6 molar HCl. To start the experiment, you must weigh the metal unknown sample. Make sure you do not make a mistake here. You may want to do this a couple of times because this is a very important measurement. Then you will run the experiment by dissolving this metal in a known amount of HCl and quantitatively collecting the hydrogen gas and measuring the volume and the temperature and the pressure of this gas so that you can use the ideal gas equation to determine the equivalence of hydrogen actually released. Finally, you'll measure the HCl remaining after this reaction. That will tell you the amount of HCl which was used up, which will tell you the equivalence of the metal unknown. So, once again, here's the agenda. You will calibrate your gas burette. You will make 1 molar HCl by dilution and standardize it by titration. Then you will run the experiment to determine the equivalent weight of your metal. You will use a burette to collect and measure the amount of hydrogen gas released by your metal. As you can see, the top portion of the burette is not calibrated. You will determine this uncalibrated volume by measuring the weight of water it contains, and this weight of water can be converted to volume using the density of water. You'll weigh the empty burette on the triple beam balance. Be careful so it doesn't roll off though. In close-up, this shows that the empty burette weighs 78.03 grams. To determine the volume in that uncalibrated top space, what you do is you fill it to the 50 milli mark upside down with water and then weigh it. When filled to the 50 milliliter mark, it weighs 132.18 grams. You also need the temperature of the water in the burette so you can determine its density. Temperature is 26.2 degrees centigrade. From the 2 masses and the water temperature, you can calculate the volume of the water which fills the burette to the 50 milliliter mark, and that is 54.33 cc's, and therefore the uncalibrated volume at the top of the burette is 4.33 cc's. At this point, do not do anything to the stopper at the top of the burette. Its exact position is now part of the calibration. You will dilute some 6 molar HCl to 1 molar HCl, but for this demonstration, we will arbitrarily just dilute 9 milliliters of the 6 molar HCl to 100 milliliters. Now you can figure out for yourself how to make 1 molar solutions. Measure out the 6 molar HCl carefully in the graduated cylinder add it to the flask, dilute to 100 milliliters with distilled water, and finally mix thoroughly. It must be mixed thoroughly. We will standardize, that is, find the exact concentration of this HCl solution by titrating with a sodium hydroxide solution of known concentration. Now, since 1 mole of sodium hydroxide reacts with 1 mole of HCl, you can determine the molarity of the HCl from the equation volume times the molarity of the base is equal to volume times the molarity of the acid. We're going to pipette 2.5 milliliters of our HCl into a flask so that we can standardize this. Now, we have, the first thing we have to do is we have to clean the pipette out. We'll use the rubber bulb and draw up this. Get this rinsed out and put it in a waste bottle here, the slop bucket. Now for keeps, we will draw this up. Here's the 0 mark up here. And we're drawing it past the 0 mark. We'll bring it right down to the 0 mark. All right, here it is at the 0 mark. And drain it in here to collect it until we get exactly to the 2.5 mark. All right, here it is exactly at the 2.5 mark. Hold it there for a second and touch it to a side. The titration will be done with the burette. First rinse and then fill the burette with the sodium hydroxide solution and bring the level at the top to the 0 mark. And then make sure there's no bubbles in the burette tip, no hanging drop on the tip, and then read the exact initial volume. As you can see, the tip is filled. There is no bubble there. There's no drip hanging from the tip. We'll put a couple of drops of indicator, phenolphthalein in, and now we'll read the initial volume. The initial reading is 0.00. We can now start adding the sodium hydroxide. We'll add it fairly rapidly at first, but we need to do that with lots of swirling here so it gets mixed thoroughly. And as you can see, well, there's just a faint pink spot being formed even now. We'll get a bigger pink spot there, so I think we'll slow this down. And now we'll add it only dropwise. Drop, drop. Getting there, bigger drops. We're very, very close to the end point, so at this point we will wash down the sides of the flask to make sure that everything is inside the flask and getting titrated. And finally we'll add another drop or 2. Drop. Okay, it's 1 drop, 4, and with that little drop hanging, we'll put it on the side, and that's the end point. With the preliminaries out of the way, we can now start the actual experiment. First, we'll weigh the metal unknown. To weigh the metal, make sure your electronic analytical balance is closed. Make sure it is level. It should read 0 to start out with, and then you'll open the door, take your metal. The weight of the metal is 0.1625 grams. You've already seen how to pipette, but we'll set up the water bath and the gas burette. To set up your gas burette, you're holding it upside down, and you must fill it all the way completely full. Use the same temperature water as you have in the bath here. Put your finger over the top, turn it upside down and under the water, and then clamp it in place. You may need to use a towel here to hold it in place. And the fun really begins. We hook everything up and we start the reaction. We've put the metal in the boat, and the tube contains the pipetted HCl. So carefully slide the boat down the tube until it floats. And that's it. To start the reaction, cover the tip of the gas inlet tube with a thin film of grease. Then insert it in the bottom of the gas burette. Then mix and sink the boat in the reaction tube. Now keep this tube in the water bath to maintain a constant temperature. And there she goes. Here's a close-up of what's happening. As soon as the boat sinks, the metal begins to react with the HCl, generating hydrogen. Everything is now dissolved so we can make the necessary measurements to determine equivalence. We now make the necessary measurements to use the ideal gas law. The volume of gas generated is 26.09 milliliters. Here's the barometric pressure, but remember, you must correct for the vapor pressure of water and also for the water level differential, which is 27.55 centimeters of water. Correcting the barometric pressure for the partial pressure of water and the difference in water levels produces a hydrogen pressure of 718.8 torr. And finally we find out how much HCl was left over and how much HCl was used up during the reaction. To determine equivalence by titration, you will quantitatively transfer the reaction solution with its remaining HCl to the titration flask. Use your funnel and wash bottle to make sure all of the contents of the tube are transferred to the titration flask. Before you raise the reaction tube, rinse off the lips so you don't lose any HCl. Now we are all set to titrate. You can add the sodium hydroxide fast at first, but keep stirring, when the red spot gets bigger, slow the titration to a dropwise addition. Now, slow it down even more. Add the last drop. That's the end. In the calculations, you will determine the equivalence used two different ways. First, using the amount of hydrogen gas liberated and the ideal gas law. Now remember, 1 mole of hydrogen gas is 2 equivalents. You will also determine the metal's equivalent weight from the equivalence of hydrogen ion used up in this reaction. Well, I think you should be able to do this, but there's one last thought that I have here. Remember that penny that we had in HCl that was giving off all that bubbling? Treating modern pennies with hydrochloric acid gives a whole new meaning to pinching pennies.